Good morning, all of you. My name is HARIBABU. I have been working as a chemistry faculty in VISHRA Junior Kalashala from last 15 years. Today I am going to discuss JEE mains, chemistry, memory based questions. First question is like this. First question is given like this. Which of the following is the strongest oxidizing agent? Which of the following is the strong oxidizing agent? Strongest oxidizing agent. Strongest oxidizing agent. In this question, he given 4 options. First option is europium plus 2. Second option is cerium plus 2. Third option is cerium plus 4. Fourth option is europium plus 3. Europium plus 3. Which one is the strongest oxidizing agent in this case? So in this case, correct option is cerium plus 4. Already you know, suppose if you take a cerium sulfate ion acts as a very good oxidizing agent in volumetric analysis. So what is the oxidation state of cerium in cerium sulfate ion? So in this case, oxidation state of cerium is cerium plus 4, that is the higher oxidation state of cerium. So generally, ion which is in higher oxidation state acts as oxidizing agent, ion which is in lower oxidation state acts as reducing agent. So in this case, cerium plus 4 has higher oxidation state, so it has the tendency to accept 1 electron to convert that into cerium plus 3. Cerium plus 4 readily gains 1 electron to convert that into cerium plus 3, which is the most stable oxidation state of cerium. It is the most stable oxidation state. So that's why cerium plus 4 can easily reduce it to cerium plus 3 because it is the most stable oxidation state of cerium plus 3. So correct answer is cerium plus 4. In this case, if you take a europium plus 2, it acts as a strong reducing agent because it is in lower oxidation state. Whenever atoms are in their lower oxidation states, act as strong reducing agents. So in this case, europium plus 2, it can readily oxidize it to europium plus 3 by gaining 1 electron, by losing 1 electron. Whenever europium exists in plus 3 state, then stability increases because it is the more stable oxidation state. So that's why europium plus 2 acts as a strong reducing agent. So in this case, which of the following is the strongest oxidizing agent? In this case, we given 4 options. First one is europium plus 2. Second one is cerium plus 2. Third one is cerium plus 4. Fourth one is europium plus 3. In this case, correct answer is cerium plus 4. Because in cerium plus 4 acts as a strong oxidizing agent in volumetric analysis because that was in a higher oxidation state. The second question in this case is the difference in melting point and the boiling point of oxygen and sulfur can be explained by. The difference in second memory based question in this case is like this. The difference in melting point and the boiling point of oxygen and sulfur can be explained by can be explained by. He given four options in this case. First option is electronegativity. Second option is electron gain enthalpy. Electron gain enthalpy. Third option is atomicity. Fourth option is ionization energy, IE. IE values. The difference in melting point and boiling point of oxygen and sulfur can be explained by. He given four options. First option is electronegativity, second one is electron gain enthalpy, atomicity and IE. So in this case, correct answer is atomicity. Because in this case, atomicity of oxygen is oxygen is 2 because oxygen is a diatomic molecule. Diatomic. Sulfur is octaatomic. That's why you can understand the difference between melting and boiling points of oxygen and sulfur like this. Next question. Third memory based question in this case is ribose present in DNA is. Third memory based question. Ribose present in DNA is. He given four options in this case. First option is a pentose sugar. A pentose sugar. Second option is present in pyranose form. Pyranose form. Third option is alpha anomeric. Carbon is present. Fourth option is present in a D configuration. Fifth option is a reducing sugar in free form. A reducing sugar in free form. Ribose present in DNA is. Generally, DNA means deoxyribonucleic acid. There are two types of nucleic acids already you know. One is RNA, another is DNA. There are two types of nucleic acids. It is a ribonucleic acid, it is a deoxyribonucleic acid. In this case, correct answer is pentose sugar. DNA contains a pentose sugar. Next, it acts as a reducing sugar in free form. In this case, carbonyl configuration of sugar is a D. These three options are correct in this case. RNA contains ribose like this, CHO. RNA contains a D-ribose, CHO, OH, CH2OH. Now H. 1, 2, 3, 4, 5. It is a D-ribose. It is present in fructofuranose form. It is present in furanose form. OH, H, H, OH, OH. It is a CH2OH. It is beta D2 deoxyribose. Deoxyribose. It is a 5-member ring. It is present in fructofuranose form. So in this case, we given 5 options like this. First option is a pentose sugar. That is correct answer in this case. Second one is a present in pyranose form. 6-member pyranose form generally contains six atoms in its cyclic ring. So it is not the correct answer in this case. Next, alpha anomeric carbon is present in this case. That is wrong answer. Here it is present in beta form. Next, present in D configuration correct. Next, reducing sugar in free state. These three are correct in this case. Next one in this case, question number 4. He given one chemical reaction like this. First one is CH3, C triple bond CH in the presence of Hg plus 2, H2 in the presence of H2SO4. Hg plus 2, H2SO4. Second reagent is hydrogen cyanide. Third one is hydrogen in the presence of nickel. So that gives P. What is P in this case? So in this case of propane reacts with Hg plus 2 in the presence of sulfuric acid. It is an example for hydrolysis reaction. Generally, propane reacts with Hg plus 2 in the presence of sulfuric acid. It is nothing but addition of water molecule according to Markovnikov rule. So here CH3, C triple bond CH reacts with Hg plus 2 in the presence of sulfuric acid. It is nothing but addition of water, H2O, H plus and OH minus according to Markovnikov rule. Whenever water is added to this according to Markovnikov rule, then it gives CH3, COH, double bond CH2. After this, it undergoes ketone dimerism to form ketone, acetone, CH3, C double bond O, CH3. First product in this case is acetone. In second step, the acetone reacts with the hydrogen cyanide. In this case, hydrogen cyanide H plus and a Cl minus. In this case, a nucleophilic reaction takes place. Already you know it contains one electron deficient carbon, that is C. Carbonyl carbon acts as an electron deficient carbon. It has a delta plus, oxygen has delta minus. Whenever acetone reacts with the hydrogen cyanide, then immediately nucleophilic reaction takes place like this. Then immediately bond migration takes place towards oxygen. So finally it gives CH3, CN, CH3, O minus. After protonation, it becomes like this: CH3, COH, CH3, Cn. In last step, this compound reacts with hydrogen in the presence of nickel. Whenever this compound reacts with hydrogen in the presence of nickel, then immediately reduction takes place to form amines. Cyanide is converted into amine. That gives CH3, COH, CH3, CH2, and H2. This is the final answer in this case. That is product B. In this case, he given 4 products like this. First option is CH3, COH, CH3, CH2 and H2. Second option is CH3, COH, CH3 NH2. Third option is CH3 CCOOH. CH3 CH3. Fourth option is CH3 CCHO. CH3 CH3. In this case, correct answer is first one. Next, another memory based question is question number 5. The most stable carbocation among the following is. Given 4 options. First option is the most stable carbocation among these. Among the following is. Among the following is. Given 4 options in this case. First option is CH2 plus double bond O CH3 bond like this. Second carbocation is CH2 plus bond like this. Third option is CH2 plus fluorine. Fourth option is CH2 plus like this. Already you know stability of carbocation depends on inductive effect, mesomeric effect like that. Stability of carbocation is directly proportional to positive inductive effect or positive mesomeric effect and inversely proportional to negative inductive effect or negative mesomeric effect. So in this case, this carbocation is stabilized by plus some effect in second case, positive mesomeric effect. Here lone pair of oxygen involving resonance with adjacent carbocations. In this case, lone pair of oxygen involving conjugation with adjacent carbocation, but it is bonded with one negative inductive effect group. That's why second of this carbocation is more stable than first. So in this case, it is bonded with a minus I effect group. It is bonded with a hyperconjugation or positive inductive effect. So in this case, first option is B. Correct answer is B. More stable carbocation is B. Next, another question. Question number 6. Question number 6. Which of the following is most reactive towards nucleophilic addition reactions? Which of the following is most reactive towards nucleophilic addition reactions? Nucleophilic addition reactions. In this case, he given 4 options. First one is para-nitrobenzaldehyde. Para-nitrobenzaldehyde. Second one is para-methylbenzaldehyde. Para-methylbenzaldehyde. Third one is benzaldehyde. Fourth one is acetophenone. Acetophenone. What is the correct order of reactivity of these 4 compounds towards nucleophilic addition reactions? So in this case, already you know, generally aldehydes are more reactive than ketones towards nucleophilic addition reactions. Aldehydes Aldehydes are more reactive than ketones. And moreover, first three options are having aldehyde group. In this case, whenever electron deficiency of compound increases, reactivity towards nucleophilic addition reactions also increases. So here, which one is more electron deficient in this case? It is bonded with the minus M group. It is bonded with the plus I group or plus M group or hyperconjugation. It is bonded with it is ketone. So in this case, the first three are more reactive than fourth one. So correct order of reactivity of these molecules towards nucleophilic addition reactions is like this. So in this case, order of reactivity is like this. Order of reactivity in this case, minus M group is greater than, hydrogen is greater than, plus M group. This is the order of reactivity. Next, ketones. So 1 is greater than, 3 is greater than, 2 is greater than 4. This is the correct order of reactivity towards nucleophilic addition reactions. Okay, next question, question number 7. Consider the following statements about water, ammonia and methane. He given 4 options like this. First option is, if it is ammonia, H2O and CH4. First option is given, all central atoms are sp3 hybridized. All central atoms are sp3 hybridized. Second option is, order of dipole moment. Order of dipole moment is like this. CH4 is less than, NH3 is less than H2O. Third option is, NH3 in the presence of water is basic in nature, NH3, H2O or Bronsted-Lowry acids and bases respectively. Fourth option is, bond angles of these molecules are like this. H2O bond angle is 104 degrees 5 minutes. NH3 bond angle is 107 degrees. CH4 bond angle is 109 degrees to 8 minutes respectively. Which of the above statements are correct in this case? Suppose if we take NH3, H2O, ammonia, what are the hybridations of central atoms in this case? All are sp3 hybridized. First option is correct in this case. Next, dipole moment of ammonia, dipole moment of methane is less than, ammonia is less than water. This is also correct answer because dipole moment of ammonia is 0. Dipole moment of CH4 is 0. Dipole moment of NH3 is approximately 1.46. 1.46 device. Dipole moment of H2O is 1.85 device. H2O has more dipole moment than ammonia and ammonia has more dipole moment than methane. Actually, dipole moment of methane is 0. Next, if you take a third option, NH3 in water is basic in nature, okay. But given NH3, H2O are Bronsted-Lowry acids. NH3 is not Bronsted acid. It acts as a Bronsted base because it acts as a proton acceptor in aqueous medium. So this is wrong option in this case. Next, bond angles of water, ammonia, CH4 all are correct. So in this case, A, B, D are correct options in this case. He given 4 options. First option is correct options in this case. Correct options are given four options again, A and B only. Second option is A, B, C only. Third option is A, B, C and D. Fourth option is A, B and D only. So in this case, fourth option is correct. A is correct option, B is correct option, D also correct option. So this is the correct answer in this case. Next question. Which of the following is most reactive towards aqueous HBr? Question number 8. Which of the following is most reactive towards aqueous HBr? He given four options in this case. First option is like this. Second compound is cyclohexene. Third compound is methyl cyclohexene. Fourth option is 1,2-dimethyl cyclohexene. Which compound is more reactive towards aqueous HBr in this case? Generally, it is an example for electrophilic addition reaction. Reactivity of electrophilic addition reactions depends on stability of carbocations. Whenever stability of carbocation increases, reactivity of electrophilic addition reactions also increases. Suppose if we add HBr to this, then what will happen in this case? Whenever HBr is added to this, then it becomes a carbocation like this. It is an example for electrophilic addition reactions. So it gives one stable carbocation. The first carbon becomes carbocation. Actually, this carbocation is stabilized by lone pair of oxygen. That is due to positive mesomeric effect. It is the most stable carbocation in this case. If you add HBr to cyclohexane, then what will happen in this case? Then it becomes 2-degree carbocation. 2-degree carbocation. If we add HBr to this, then it becomes 3-degree carbocation. If you add HBr to this, then it becomes again 3-degree carbocation. So it is this carbocation, this is 1 degree carbocation, but it is stabilized by positive mesomeric effect. It is 2-degree carbocation stabilized by hyperconjugation. It is a 3-degree carbocation stabilized by hyperconjugation. It is also 3-degree carbocation stabilized by hyperconjugation. So which one is the more stable carbocation in this case? First one is the more stable carbocation. Whenever stability of carbocation increases, reactivity towards electrophilic addition reactions also increases. So first option is correct answer in this case. Next question. Question number 9. That the freezing point of water process is non-spontaneous and it becomes spontaneous at the boiling point. So the correct option is at the freezing point of water, the process is non-spontaneous. And at the boiling point of water, and it becomes and it becomes spontaneous at the boiling point. He given four options in this case. The correct option is, first one is delta H is positive and delta S also positive. Second option is delta H is negative, delta S is negative. Third option is delta H is positive, delta S also positive. Fourth option is delta H is negative, delta S is positive. Which one is correct option in this case? Actually, this concept depends on delta G values. Spontaneous, non-spontaneous, that is related to change in free energy. How do you know one thermodynamic term to decide spontaneity? That is the delta G. If delta G is negative, then it becomes spontaneous. If delta G is positive, then it becomes non-spontaneous. Already you know the relationship between delta G and delta H. We know that delta G is equal to delta H minus T delta S. Whenever delta H is positive and delta S also positive, then total term becomes, if temperature is low, if temperature is low, then it becomes positive. So it is a non-spontaneous. It becomes non-spontaneous. At a low temperature, delta G sign becomes positive. So this is non-spontaneous. If temperature is high, then delta G becomes, in this case delta H is positive, T delta S also positive, but temperature is high. Whenever temperature is high, then delta G sign becomes negative. So in this case it is spontaneous. So whenever delta H and delta S both are positive, then freezing point of freezing process becomes non-spontaneous and the boiling process becomes spontaneous. Next question. Consider the given reactions and choose proper solvent. He given two reactions. First reaction is like this. Question number 10. Reaction 1. N-butyl chloride CH3, CH2, 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 Cl in the presence of OH minus gives CH3, CH2, 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 OH. This is an example for SN2 reaction. Substitution reaction, nucleophilic substitution reaction. Next reaction 2. In this case, we given CH3, same N-butyl chloride, CH3, CH2, 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 Cl. In the presence of trimethylamine gives CH3, CH2, 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 N plus R. This is also an example for SN2. Already you know, for SN2 reactions, polar aprotic solvent is formed. So here polar aprotic solvents are favorable for SN2 reactions. SN2 reactions. We given 4 options in this case. First option is reaction 1, polar protic. Next reaction 2, polar aprotic. Second option is reaction 1 is polar aprotic. Next reaction 2 is polar protic. Next third option is reaction 1 is polar aprotic. Reaction 2 is polar aprotic. Fourth option is reaction 1 is polar protic. Reaction 2 is polar protic. So which one is correct option in this case? Both are example for SN2. Generally, polar aprotic solvents are available for SN2. So in this case, option 3 is correct. Option C correct. Reaction 1 is polar aprotic. Reaction 2 is polar aprotic. So this is the correct option in this case. Next question. Question number 11. When X grams of benzoic acid reacts with sodium bicarbonate, 11.2 liters of CO2 is released at 273 Kelvin and 1 atm pressure. Calculate mass of benzoic acid in grams. So in this case, benzoic acid reacts with the sodium bicarbonate to form carbon dioxide. So before going to solve this problem, we must try the balanced equation, stoichiometric equation. Without stoichiometric equations, we can't do this. So write down the stoichiometric equation that will be like this. So in this case, benzoic acid reacts with the sodium bicarbonate, 1AHCO3. Whenever benzoic acid reacts with the sodium bicarbonate, gives sodium benzoate CONA plus H2O plus CO2. Already it is balanced. So here 1 mole of benzoic acid combines with 1 mole of sodium bicarbonate to form 1 mole of sodium benzoate and 1 mole of water and 1 mole of CO2. That is according to stoichiometric equation. But in this case, he given 11.2 liters of CO2. 11.2 liters of CO2, that is equal to half mole. Half mole of CO2. So according to this equation, 1 mole of benzoic acid gives 1 mole of CO2. But in this case, he given half mole of CO2. Half mole of CO2 is from half mole of benzoic acid. Half mole of benzoic acid. So what is the formula of the molecular weight of benzoic acid? Benzoic acid formula C6H5 COOH. What is the molecular weight of benzoic acid? 122. 122 grams is the weight of 1 mole of benzoic acid. 1 mole is equal to 122 grams. So then what about the half mole of benzoic acid? That is 61 grams. So this is the correct answer. Next question. If the solubility product of chromium hydroxide is 1.6 into 10 power minus 30 molar, the molar solubility of salt in water is 1.56 into 10 power minus x, then find the value of x. If the KSP of chromium hydroxide is 1.6 into 1.6 into 10 power minus 30 m power 4. The molar solubility of salt in water is S for this is equal to 1.56 into 10 power minus 6. Find x. Find x value in this case. Already you know it is an example for AB3 type electrolyte. AB3 type. AB3 type. Whenever it is dissolved in water, gives A power plus 3 plus 3B minus. Solubility of this is S. Solubility of this one becomes 3S. Already you know solubility product KSP is equal to S into 3S whole cube, that is equal to 27 S power 4. So KSP is equal to 27 S power 4. S power 4 is equal to KSP by 27 in this case. So that is equal to KSP value given 1.6 into 10 power minus 30 by 27. So therefore S is equal to, if you solve this, then we will get S is equal to 1.56 into 10 power minus 8. So therefore X is equal to 8. That is the correct answer in this case. Next question. In this case, a 2.32 into 10 power 3 kg of Fe3O4 reacts with 2.8 into 10 power 3 kg of carbon monoxide according to the following reaction. Question number 12. In this case, Fe3O4 reacts with carbon monoxide to form iron and carbon dioxide. If x kg of iron is formed, find the value of x. In this case, given like this. Weight of Fe3O4 is 2.32 into 10 power 3 kgs. Next, weight of CO is 2.8 into 10 power 3 kgs. So in this case, Fe3O4 combines with the CO to form iron and carbon dioxide. He given weights of Fe3O4 and CO like this. So before going to solve this problem, we must balance this equation. Stoichiometric equation is important. So all of you balance this equation first. So here Fe3O4 combines with 4 moles of CO to form 3 moles of iron and 4 moles of CO2 gas. So according to this, so here the equation is like this. Fe3O4 combines with 4 moles of CO to form 3 moles of iron and 4 moles of CO2. So 1 mole of this combines with 4 moles of carbon monoxide, that gives 3 moles of iron and 4 moles of CO2. This is according to stoichiometric equation or according to balanced equation. So in this case, the given weight of Fe3O4 2.32 into 10 power 3. Weight of CO is 2.8 into 10 power 3 kgs. So in this case, which one is limiting reagent? So in this case, product depends on, you have to find weight of iron in kgs. The amount of iron formed in this case depends on limiting reagent. Which one is limiting reagent in this case? Fe3O4 is limiting reagent. Limiting reagent. It is the limiting reagent in this case. So in this case, molecular weight of this is 232. 232 grams of Fe3O4 combines with 4 moles of this. What is the molecular weight of carbon monoxide? 12 plus 16, 28. So 232 grams of Fe3O4 combines with 4 into 28 grams of carbon monoxide to form 3 into atomic weight of iron 56 nearly. 3 into 56 grams of iron plus 4 into 44 grams of CO2. So in this case, the amount of iron formed depends on amount of Fe3O4. So according to this equation, 232 grams of Fe3O4 gives 3 into 56 grams of iron. That is given weight of Fe3O4 2.32 into 10 power 3 kgs. Convert this into grams. So that is equal to 2.32 into 10 power 6 grams. 2.32 into 10 power 6 grams of Fe3O4 gives how much amount of iron? Cross multiplication. 2.32 into 10 power 6 into 3 into 56 by 232. That is the correct answer. So correct answer is that is equal to 3 into 56 into 2.32 into 10 power 6 by 232. So that is equal to approximately 16.80 into 10 power 3 grams. We should convert that into kgs. So by 10 power 3. Cancel, that is equal to 1680 kgs. Like we can do. Next question. Consider the following reaction of a complex compound. Question number 13. We given one chemical reaction of complex compound like this. CO, Cl2, 5 moles of ammonia in the presence of water gives 3 moles of ions. 3 moles of ions. The same compound, whenever this compound is dissolved in AgNO3 solution, it gives 2 moles of AgCl. 2 moles of AgCl precipitated. The formula of the complex is actually this complex compound reacts with 2 moles of AgNO3 to form 2 moles of AgCl. He given clearly 2 moles of AgCl. So whenever compound having 2 chlorine atoms as a counterions or outside of the coordination sphere, then that can react with 2 moles of AgNO3 to form 2 moles of AgCl as a precipitate. So the molecular formula of the given compound is like this: CO NH3 5Cl and actually that is a Cl3 Cl2. This is the molecular formula of the compound. So if molecular formula of the compound is like this, whenever this compound is dissolved in water, then immediately it undergoes dissociation into its ions. So that gives CO NH3 5Cl plus 2Cl minus. So it is one complex cation, it is 2 simple anions. So 1 plus 2 is equal to 3. So whenever this compound is dissolved in water, then immediately it gives 3 moles of ions. Whenever this compound is dissolved in AgNO3, actually this compound contains a 2Cl minus as a counterions. So here Cl minus anions require 2 moles of AgNO3 to form 2 moles of AgCl. If molecular form of the compound is like this, then only that gives 3 moles of ions in aqueous medium, and that gives 2 moles of AgCl in the presence of AgNO3 solution. Next, question number 14. In this case, is given like this: an electron jumps from A to C by emitting a wavelength of 2000 angstroms, and also jumps from B to C by emitting a wavelength of 6000 angstroms. Then wavelength of that electron if it jumps from A to B. So in first case, given 3 spectral lines like this: 1, 2, 3. In first case, electron jumps from, just assume it is A, B, C. In first case, electron jumps from A to C. Wavelength of this transition is, lambda of this transition is 2000 angstroms. That is the first step in this case. In second step, electron jumps from A to B. In third case, electron jumps from B to C. Wavelength of this transition is 6000 angstroms. 6000 angstroms. What is the lambda for this A to B transition? Already you know one simple relation, that is 1 by lambda is equal to 1 by lambda 1 plus 1 by lambda 2. That is obtained from E is equal to Hc by lambda. Just assume it is a Hc by lambda, this is a Hc by lambda 1, this is Hc by lambda 2. Then we will get 1 by lambda is equal to 1 by lambda 1 plus 1 by lambda 2. Wavelength of this radiation is equal to, AC radiation is equal to 2000 angstroms. So 1 by 2000 is equal to, we have to find lambda AB. It is AB, just assume it is BC, it is a lambda of AC. So 1 by 2000 is equal to 1 by lambda AB plus wavelength of this is 6000, 1 by 6000 angstroms. So therefore 1 by lambda AB is equal to 1 by 2000 minus 1 by 6000. If you solve this, then we will get the lambda of AB. Lambda AB is equal to, on solving this, we will get lambda AB is equal to 3000 angstroms. 3000 angstroms. Lambda is equal to 3000 angstroms. We will get 3000. Next question number 15. In this case, we given one reactant. A student synthesizes the compound given below. The compound is like this. Say double bond OH. A student synthesizes the compound given below. The compound is like this. By using one of the following compounds available in the laboratory and using following reagents. So he given like this. He given the sequence of reactions like this. Reactant in the presence of NBS. NBS means N-bromosuccinamide. Next, WCA. A in the presence of Me3O minus K plus in the presence of tertiary butyl alcohol. COH gives B. B in the presence of B2H6 and THO. Next, H2O2 in the presence of OH minus gives C. C in the presence of PCC. PCC means a pyridinium chlorochromate. That gives D. So that is nothing but this. D compound is like this. So you given again 4 options in this case. Choose the suitable compound which can be used as a reactant. Which one is correct reactant to get this compound? According to these reactions. First option is double bond CH2 methyl CH3. Second one is like this. Third one is like this. Fourth one is like this. Which one is correct option in this case? Which compound gives this D compound? Which reactant gives this D? According to these reactions. So in this case, correct option is this. C is correct option in this case. Because if you take C, that is 1, 2, 3 methyl cyclohexene. If you take 3 methyl cyclohexene, whenever it is treated with NBS, N-bromosuccinamide. What is the importance of N-bromosuccinamide? It is used for allylic bromination or benzylic bromination. Allylic or benzylic bromination. Which one is allylic carbon in this case? Allylic hydrogen. This is allylic hydrogen. So this hydrogen is replaced by bromine free radical. So that gives. So substitution takes place indirectly in this case. So here 3-degree hydrogen or allylic hydrogen is replaced by bromine. That is A product in this case. Whenever A reacts with potassium tertiary butoxide in the presence of tertiary butyl alcohol. So in this case, immediately elimination takes place. It is an example for E1 elimination. E1. In this case, the base is bulky. So reaction takes place through E1. O minus and K plus in the presence of tertiary butyl alcohol. Elimination takes place. So in this case, elimination takes place according to Hoffman rule. So we will get a less substituted alkene in this case. Remove this hydrogen and bromine. So finally it gives CH2. Remove hydrogen from this CH2 and H. Elimination takes place in this manner. Remove hydrogen from methyl, bromine from this carbon. So it gives one alkene. So this elimination takes place according to Hoffman rule. That is C in this case. So that is B in this case, sorry. So whenever B is treated with B2H6 in the presence of H2 wood and OH minus. So this is nothing but H now water according to anti-Marconi rule. So indirectly in this case H now water H plus and OH minus takes place according to anti-Marconi rule. So that gives CH2OH. It is C. Whenever it is treated with the PCC, pyridinium chlorochromate, that is used to convert primary alcohols to aldehydes. So that gives D. D is nothing but like this. You can understand this sequence of chemical reactions. Thank you.